Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so today we're going to look into what we call the lecture for part 2 of topic we call matrices and system of linear equation. Okay, so for today we're going to look into the determinant of matrices. Okay, so I do hope that you have your lecture notes in your hand right now. Without wasting so much time, let's continue with the first part of this topic here. Okay, so at the end of this topic, students should be able to find the minor and cofactors of a matrices and determinant of a matrix. So, which I think that all of you will be exposed with the determinant for matrices last time in Form 4 and Form 5. With the size of 2 times 2 matrices. Okay, for example, if this is a matrix of A, okay, we have A, B, C, and D. So the determinant of A equal to AD minus BC. So look at this, look at this. It's a big, we call big square bracket, but this one have no, the shape of this one here is just like a pole. So this sign of the determinant. So AD minus BC. For example, we have this determinant of A equal to, for matrix of 3, 5, 1, negative 1. So then 3 times 1 equal to negative 3 minus 5 times 1 equal to 5. Then we get negative 8. Okay, so the minor of matrices, we call the minor of IJ is determinant of n minus 1 multiplied with n minus 1 matrix obtained by deleting the ith row and jth column of A. So for example, when we have matrix of A with a size of 3 times 3, okay, this is a matrix of A with a size of 3 times 3. So the minor of 2, 1, minor of 2, 1 in this case, okay, by deleting the ith row and jth column of A. So row number 2, we delete or hide the element in row number 2 and column 1 here. So what we have here right now is 1, A12, A13, A32, and A33. Okay, so this is what you have. Then cross multiply A12 multiplied with A33 minus A13 multiplied with A32. Okay, so that's it. Now cofactor Cij is element of Aij. Okay, so just now we look into the we discussed on this part just now. We talk about minor, okay, in all the explanation here. Then look at the cofactor. This is minor and end up with this one here, negative 1 to the power of I plus j. It gives you the cofactor. Okay, for example, find the minus and cofactor of A11 and A32. So class, let's say for minor m of the, okay, these all the element in matrix of A. Element for A11, A12, A13, A21, A22, and A23, and A31, A32, and A33. Okay, so the minor and cofactor of the element of A11, A11 is 1 here. So minor of 1, 1, we hide, okay, we hide the element in row number 1, hide the element in row 1, and column 1. So what you can see here now? So we got 4, 2, 4, 3. 4, 2, 4, 3. So then 4 times 3 equal to 12 minus 2 times 4 equal to an 8. So 12 minus 8 equal to 4. Okay, next. So the minor of 3, 2. So for this one here now, minor of row number 3, and column 2. So tell me guys, what you can see here now? What's left then? 1, negative 1, 3 and 2. 1, negative 1, 3 and 2. So then 1 times 2 multiplied with 2 equal to 2 minus negative 1 times 3 equal to negative 3. So negative multiplied negative, positive. So 2 plus 3 equal to 5. So this is a minor of 1, 1 and minor of 3, 2. So to find the cofactor of C11, okay, it is a negative 1 to the power of 1 plus 1, and then the minor of 4, 2, 4, 3. So the result of this, where we get it earlier, which is equal to 4. So negative 1 power of 1 plus 1. 1 plus 1 equal to 2. Negative 1 squared equal to positive 1. And the result of this minor, which is equal to 4, multiplied with 4, then it is equal to 4. Cofactor of 3, 2. So we got negative 1 to the power of 3 plus 2. And the minor of 3, 2 with 1, negative 1, 3, 2, where as we get earlier here, minor of 3, 2 equal to 5 and negative 1. 3 plus 2 equal to 5. So negative 1 to the power of odd numbers, which is 5 here, equal to negative 1. Multiply with 5 equal to negative 5. Okay. Okay. Okay, so now we can find the minor of every single element of the matrix one by one. Okay, so the process of this, we keep repeating the process again and again 9 times. Okay, 9 times, because we have a minor of every single element. Minor for 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. So minor for each of these, we're repeating the process 9 times for the matrices with a size of 3 times 3. Okay. And cofactor class for this one, we can see the pattern of this. Okay, negative 1 plus 1 equal to 2. Negative 1 power of, look at this one here. Okay, if I plus j give you an odd numbers, if I plus j, the index or the power of these numbers, I plus j is an odd numbers, then it gives you the result with a negative. And if this is an even numbers, then it gives you positive 1 or positive sign. So if you can see here, the sign we call change it, we call this is the pattern of positive, negative, positive, negative, positive, negative, positive, negative, and positive. So we come up with this one here: positive, negative, positive, negative, positive, negative, positive, negative, positive. So now find all the minors of A. Hence, from the minor, form the minor matrix of A and cofactor matrix of A. Wait a minute. Okay, so I'm gonna write down the matrix of A here. Okay, the matrix of A, 1, 2, 0, 3, 1, 1, and 2, 0, 3. 1, 2, 0, 3, 1, 1, 2, 0, 3. Okay, now, minor of 1, 1. Okay. We hide the element in row 1 and column 1. So what's left here now? We got 1, 1, 0, 3. 1, 1, 0, 3. Then 1 multiplied with 3 equal to 3 minus 1 multiplied with 0 equal to 0. Then it is equal to 3. The first minor for this question. Now for M12. For M12, we hide the element in row number 1 and column 2. So what's left here now? You can see it clearly that it is 3, 1, 2, 3. 3, 1, 2, 3. So 3 times 3 equal to 9 minus 1 multiplied with 2 equal to 2. 9 minus 2 equal to 7. Then M13. So M13, before that, okay, we hide the element in row 1 and column 3. So what you can see here now, what's left? We have 3, 1, 2, 0. 3, 1, 2, 0. So 3 times 0 equal to 0 minus 1 multiplied with 2 equal to 2. Then we get negative 2. Then we move to the second row. Okay, I write down all the minor for second row. M21, M22, and M23. Okay, so the first one then, for M21, we hide the element in row number 2 and column 1. So what's left here now? We got 2, 0, 0, 3. 2, 0, 0, 3. So 2 times 3 equal to 6 minus 0 times 0 equal to 0. Then we got 6. Then next, okay, it's time for minor 2 and 2, meaning we hide the element in row number 2 and column 2 here. So then, what's left here now? 1, 0, 2, 3. 1, 0, 2, 3. So 1 times 3 equal to 3 minus 0 times 2 equal to 0, then equal to 3. Okay, so then next, no. And now it's time for minor 2, 3, row element in row 2 and column 3 here. Okay, so we got 1, 2, 2, 0. 1, 2, 2, 0. 1 multiplied with 0 equal to 0 minus 2 times 2 equal to 4. Then we get negative Okay, so now let's clear all this. It's time for us to find the minor for element in row 3. 3, 1, 3, 2, and 3, 3. So we hide the element in row 3 and we begin with column number 1. So what you see here now, we got 2, 0, 1, 1. 2, 0, 1, 1. So it's time for we call multiply 2 times 1 equal to 2 minus 1 0 multiplied 1 equal to 0. We got 2. Then next, we hide the element in row 2. So there's a left here with 1, 0, 3, 1. 1, 0, 3, 1. So 1 times 1 equal to 1 minus 0 times 3 equal to 0, then equal to 1. Okay. And erase this and highlight for minor 3, 3, hide element in row 3 and column 3. So what's left here now? We got 1, 2, 3, 1. 1, 2, 3, 1. So 1 times 1 equal to 1 minus 2 times 3 equal to 6. So 1 minus 6 equal to negative 5. So now class, this is the process that we call the process that involved to find the minor for each of the element for matrices of 3 times 3. So now, to find the cofactor, to get a cofactor of this, let's list down all this one by one. 3, 7, negative 2, 6, 3, negative 4, 2, 1, negative 5. Okay. The minor of matrix A, okay, the minor here is 3, 7, negative 2, 6, 3, negative 4, and 2, 1, negative 5. So these are the minor of matrices of A. So cofactor of matrix A, so please remember this, the pattern of positive, negative, positive, negative, positive, negative, positive, negative, positive. So now, positive 1 multiplied with 3, then we got 3 here. Negative multiplied with 7, negative 7. And positive multiplied with negative 2, negative 2. Okay, 3, negative 7, negative 2 then, okay. So negative multiplied with 6, we get negative 6. Positive multiplied with 3 equal to 3. And negative multiplied with negative 4, positive 4. Positive times 2 equal to 2. Negative times 1 equal to negative 1. And positive times negative 5 equal to negative 5. Okay, so this is it. Cofactor of the matrices of A. Okay, so conclusion here. So we like to be called to find the minor. We are going to hide or delete the ith and jth row of the column A according to the order that been given there. And cofactor is negative 1 to the power of I plus j multiplied with the minor of ij. Okay, so let cofactor expansion here. So determinant of A equal to summation of the element of ij multiplied with the minor of aij. Okay, so if this is a matrix of A, okay, element of the matrix of A, by expanding the first row, so guys, girls, this is all the element in the first row, A11, A12, and A13. And every single element multiplied with its cofactor, C11, C12, and C13. Okay, so now find determinant of A by expanding along the first column. First column, we got 3, 1, 5. Okay. So now, the first element, okay, expansion along the first column, the element in the first column, which is 3, 1, 5. So now, determinant of A equal to we are going to find the cofactor for each of the elements. Sorry. Let's find out the cofactor first. Then the first is we're going to find the minor of 1, 1 here, which is if we hide the element in first row and the first column, we will get negative 2, 7, negative 1, 10. Okay, negative 2, 7, negative 1, and 10. I hope that you all still remember the process that I showed you just now. Recall before this, in this video, just now we intend to find the minor and the cofactor of these matrices. Okay, so the minor of the first one here, we hide the element in the first row and first column, and we got negative 2, 7, negative 1, 10. So now, negative 2 times 10 equal to negative 20 minus 7 times negative 1 equal to negative 7. So negative times negative, positive. So negative 20 plus 7, negative 13. Minor of, okay, for 1 here is minor of row number 2 and column 1. Okay, never mind. I repeat the process of this. Recall, hide the element in row 2 and column 1. Okay, so now what's left here? We got negative 1, 4, negative 1, 10. Negative 1, 4, negative 1, and 10. Negative 1 times 10 equal to negative 10 minus 4 times negative 1 equal to negative 4. Negative and negative positive. So then negative 10 plus 4 equal to negative 6. Okay. Then next, we hide the element. Okay, before that. For this 5, the minor of row number 3 and column 1 and 3, 1. Okay. So then we hide the element in row 3 and column 1. Okay, so what's left here now? We got negative 1, 4, negative 2, 7, negative 1, 4, negative 2, 7. Negative 1 times 7 equal to negative 7 minus 4 times negative 2 equal to negative 8. Negative times negative become positive, so negative 7 plus 8 equal to 1. Okay, so we got negative 13, negative 20 plus 7, okay, negative 10 plus 4, yes, and negative 7 plus 8, there you go. Okay, now cofactor of 1, 1, which is negative 1 to the power of 1 plus 1 multiplied with a minor, which is here now is negative 13. Okay, so negative 1 plus 1 equal to 2. So negative 1 squared equal to positive 1. Positive times negative 13, negative 13. So cofactor of 2, 1. It is now negative 1 to the power of 2 plus 1. And the minor is given here now. Okay, what we get here just now is negative 6. So 2 plus 1 equal to 3. Negative 1, power of odd numbers, it gives you negative 1. Multiplied with negative 6, it gives you, okay, the answer is 6, positive 6. And cofactor of 3, 1 equal to negative 1 to the power of 3 plus 1. And the minor equal to 1 here. 3 plus 1 equal to 4. Negative 1 to the power of 4 equal to positive 1. So 1 plus multiplied with 1 equal to 1. Okay, so now determinant of A equal to the summation of, for example, okay, so it is a summation of the element of A11, okay, element in the we call row and column 1, here 1, 1, 3, multiplied with the cofactor of 1, 1, which is negative 13, plus with the element in row 2 and column 1, which is 1 here, multiplied with the cofactor of 2, 1, which is 6, plus with the element in row number 3 and column 1, which is 5 here, 5 multiplied with the cofactor of 3, 1, which is 1 here. So then, 3 times negative 13, negative 39, plus 6 plus 5, okay, 6 plus 5 equal to 11, then 39 minus 11 equal to negative 28. Okay, class. This is a question specifically wants you to find the expansion along the first column. Let's say I spend the time with all of you with this one here. Let's change the question and see whether we will get the same final answer as we got in this first solution here. Okay. Okay. Right now, we have solved the questions to find the expansion along the first column to find the determinant of A. Okay, using the first column, and the answer is negative 28. Let's keep this for a while. Okay, let's say if I change the question here, change this along, let's say, second row, which is 1, negative 2, and 7. Okay, let's try. Okay, first one here. No. Let's say using the first, recall the second row here, we are going to find the minor of, let's say, 2, 1. Okay, let's say minor of 2, 1, minor of 2, 2 here, and minor of 2, 3. Okay. So firstly, we are going to clear, we call hide the element in row 2 and column 1. So what you see here now, we got negative 1, 4, negative 1, 10. Negative 1, 4, negative 1, 10. Negative 1 times 10 equal to negative 10 minus 4 times negative 1 equal to negative 4. In negative times negative become positive, so negative 10 plus 4 equal to negative 6. Then next, this one here. Okay, so for minor of 2 and 2, we had already hide the element in row 2, and now we are going to hide the element in row 2 here. Column 2, sorry. So what's left here now? We got 3, 4, 5, and 10. 3, 4, 5, and 10. So then 3 times 10 equal to 30 minus 4 times 5 equal to 20. So 30 minus 20 equal to 10. Okay. And next, let's hide for minor of 2 and 3. We already hide the element in row 2. It's time for us to hide the element in column 3. Okay. So what's left here now? We got 3, negative 1, 5, negative 1. 3, negative 1, 5, negative 1. 3 times negative 1 equal to negative 3 minus 5 times negative 1 equal to negative 5. So negative become positive. Negative 3 plus 5 equal to 2. Okay. So now, we have complete the mission of to find the minor or element in row 2. Let's find out the cofactor of 2, 1, which is negative 1 to the power of 2 plus 1. And the minor is here negative 6. So 2 plus 1 equal to 3. So negative 1 power of odd numbers, we got negative 1 multiplied with negative 6 equal to 6. Cofactor of 2, 2. For negative 1 to the power of 2 plus 2. And the minor equal to 10. Okay, so 2 plus 2 equal to 4. Negative 1 to the power of 4 equal to positive 1. Multiplied with 10 equal to 10. And cofactor of 2, 3, which is negative 1 to the power of 2 plus 3. And the minor given here is 2. What we get here just now is 2 here. So 2 plus 3 equal to 5. Negative 1 power of 5 equal to negative 1. Multiplied with 2, then we got negative 2. Okay, so now determinant of A equal to expansion along the second row, we got negative 1. No, we got 1 there. 1 multiplied with cofactor of 2, 1 equal to 6. Plus with negative 2 and negative 2 and cofactor which is equal to 10 and 7 multiplied with cofactor of 2, 3 which is negative 2. Okay, so 6 negative 2 times 10 equal to negative 20 and 7 times negative 2 equal to negative 14. So negative 20 minus 14, negative 34. And negative 34 minus negative 34 plus 6, negative 28. So compare with this one, where we recall expansion along the first column, second row, and you may try with using the second column or third column or any row or any column, you supposedly get exactly the same correct answer. Okay, which is negative 28 for this question. Okay, right. Example 4, find the determinant of A by using expansion of the cofactors. Okay, class, for this kind of matrices of A, where you can see there is a 0, 0, and 0. Choose the row or column that has the most zeros. Okay, you know why? Because any value, okay, any value of, we call the cofactor of these matrices of A, when multiplied with the element of 0, it will straightly give you, we call the value equal to 0 there. Okay, so look at this one here now. Okay. Um, okay, never mind. I'll do it here. So just imagine that if determinant of A equal to, I'll choose the element in row 2. Row 2 we have 0, 0, 1. Or you may also choose the element in column 1, 2, 0, 0. Okay. We got 0 here and the minor or cofactor of C11. Okay, choose element in row 2. 0 and cofactors of okay 2, 1 times with negative 1 to the power of 2 plus 1 and the minor. Okay, hide the element in row 2 and column 1. So we got negative 1, negative 3, negative 1, negative 3, 5, negative 4. Plus with, okay, another 0 here. Then negative 1 to the power of, okay, this in the position of row 2 and column 2. So 2 plus 2. And the minor here, we hide element in row 2 and column 2. We got 2, negative 3, 0, negative 4. 2, negative 3, 0, negative 4. Plus with, okay, we got 1 here. And cofactor with negative 1 to the power of, okay, element in row 3, row 2 and column 3. 2 plus 3. Then hide the element in row 2 and column 3. You get 2, negative 1, 0, 5. 2, negative 1, 0, 5. So guys, girls, whatever value that we get here, when you multiply with a 0, it's really completely give you 0 here. If you get any value for cofactors for the second part here and multiply with a 0, it straightly give you a 0. So these are only things left here now. So it is 0 plus 0 plus, okay, 2 plus 3 equal to 5. 1 and negative 1 to the power of 5 is negative 1. And here 2 times 5 equal to 10 minus negative 1 times 0 equal to 0. So then 0, 0, negative 1 times 10 equal to negative 10. Okay, so it's a simple idea when we have most entries with the zeros then. Okay, now for this question, the properties of determinant, determinant of A transpose. A transpose means that, for example, A, we got A, B, C, D, E, F, G, H, and I. So then A transpose equal to, we change the element, row become column, and column will become row. Okay, A transpose means that A, B, C as an element in row number 1, that we change it into A, B, C. D, E, F, the element in second row, become the element in second column. And element in the third row, G, H, I, become the element in the third column, G, H, I. So that is the idea of transpose. Okay, A, T stands for transpose. And then determinant of AB equal to determinant of A multiplied with determinant of B, and determinant of K, any scalar of K multiplied with the A equal to K to the power of N, and multiplied with the determinant of A. So, and if the corresponding element are equal in any two row or column in the matrix A, then determinant of A equal to 0. Okay, and if any two rows or column interchange in the matrix F of A, any two rows or column interchange the position, then the new determinant is negative determinant of A. Okay. So now, for this one, okay, if you have your lecture notes with you right now, okay, if you have lecture notes with you right now, let's solve this question referring to this. Okay, so determinant of A transpose, if determinant of A equal to 10, then, okay, so for this one here, straightly we come up with determinant of A transpose is also equal to 10. Okay, if determinant of A, B, okay, find determinant of AB if determinant of A equal to 10 and determinant of B equal to -2. So for this one here, determinant of AB equal to determinant of A multiplied with determinant of B, which is 10 multiplied with -2 equal to -20. Okay, find determinant of this. Okay, what's the difference between this x4y 1 3 -2 w 4z? What's the difference? Okay, look at the original matrices of this x y. Okay, x1w, we get x1w. Element in second column y -2z 4 3 4. Okay, and the element in row column 3 4 3 4, and here is y -2z, which I think that for this one, okay, the element in second column and the element in third column, for this question of C, they interchange. Okay, so when it comes to this, if determinant of the original matrix of A equal to 10, then if we change the position between column 2 and column 3, so refer to the notes again. Okay, refer to the notes again. Okay, sorry. Okay, if any two rows or column interchange in the matrix, okay, any two rows or column interchange in the matrix, then the new determinant is negative A, negative determinant of A. So for this one here, determinant of this, okay, determinant of x4y 1 3 -2 w 4z, okay, determinant here, sorry, equal to -10. Okay, it is negative determinant of A. Okay, and then for the last final question here, for question of D, find determinant of A if x equal to w and y equal to z. So let's come up with the new A here. X equal to w, we have x and w. Y equal to z, we have y and z. So what's going to happen here? X, y, 4, 1 -2 3, and w equal to an x. Z equal to y, and 4, we have 4 here. The new A star, matrix of A star here. So then, find determinant of A or the determinant of new matrix of A star here. If this one, so please refer to this notes again. Okay, refer to this notes. If the corresponding element are equal in any two row or column. So look at this one here now. The element in row 1, xy4, and row 3, xy4. There are two rows with an equal element equal x and x, y and y, 4 and 4. So determinant of A star here equal to 0. Okay, so that's a solution of all these questions. Example 5, according to this explanation of the properties of determinant 1, 2, 3, 4, and 5, then I'll explain all here by using this example. Okay. So now conclusion, guys, girls. To find the minor and cofactor, we delete the ith row and j column of the A for the minor, and then to find the cofactor, we multiply with -1 to the power of I plus j and multiply with the minor. And to find the determinant, we expansion of the cofactors. You can choose any row or any column, okay, and it will give, you should get one. You should get one correct answer. Okay, so for this one, which I think that I'll let all of you try by yourself. Okay, never mind. Which I think that is an equal. This is only an exercise. So I let all of you to try with the final answers given there. Okay, with the final answers given. So good luck. That's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.